So last time we saw that the equation of an ellipse, the equation of an ellipse will have a form x squared over a squared plus y squared over b squared is equal to 1. And this was for an ellipse centered at the origin. So this was for an ellipse that was centered at the origin, something like this. So its center was here, and then we had the x and the y there. Okay, so this is what we had. And then here, of course, A was basically just the distance from the center here coming up to where the vertex is. So up to here. So if you're going to the left, it's going to be minus A. And going this side, this was always going to end up as minus plus A. So this is what we had if it was centered at the origin. Now, one other thing that we mentioned is if you compare the denominators of x and y, let's say the denominator here is, let's say, a 9. Let's start with the denominator here being 16. And let's place the denominator there being 25. Let's say something smaller. Let's say 9. So by checking the denominators, you can conclude whether you are dealing with an ellipse which is more vertical, like that. I would say measure in the vertical or measure in the horizontal. In this case, if you see that the denominator of the x term is bigger than the denominator of the y squared term, as in the denominator of the x squared, which is the 16, and the denominator of the y squared, these are the ones you have to compare. So if the denominator of the x squared is bigger than the denominator of the y, then you're dealing with something which is more horizontal. But if the denominator of the y is the one greater than the denominator of the x term squared, x squared term, then you're dealing with an ellipse which is more in the vertical. So again, we'll see examples to deal with that. So let's look at a few examples to just understand how this one goes. So I have a few examples here. Let's see how we approach them. Consider the first one where we have x squared over 4 plus y squared over 9 is equals to 1. So in this case, we want to find the foci, the vertices, and hence sketch the ellipse. So for simplicity, I always start with a sketch so that we can easily pick where the vertices are and everything else. So how do you do it? Well, the first thing, again, I compare the denominators, and I notice that the bigger one is the one for y, and the one for y is a 9. So what does that tell me? Well, when sketching this, I know the measure for this ellipse is in the vertical axis. So we're seeing an ellipse which is more vertical than horizontal. Okay, so we're dealing with an ellipse which is more like this. Make it bigger. Okay, so more like that. Okay, so now that that is done, you know to say again, A is basically the distance from this to the top part, and that is going to be A, and then going down, this is going to be where minus A will be. Now, here, of course, you have to be very careful. For an ellipse, what becomes your A or your A squared term depends on which one is bigger. So since I'm measuring A in terms of from here to there in the legs, so I would take A squared to be the one which is bigger. In this case, it is that 9. So I'll have A squared is equals to 9. So that I can say A is equals to plus and minus 3. So on top, we're dealing with a 3. And down here, we're dealing with the minus 3. What else? Next, we have the b squared term. So since this is the a squared term, b squared has to be this one. So we're seeing b squared is equals to 4. So that b is plus and minus 2. Once we have what b is, you remember that relationship, that b squared is equals to a squared minus c squared. So this is what we had last time. So once you have the expression, or with this equation remembered, you can easily use it to find what c is. All you should remember is that for an ellipse, C is the distance from the center to the focus. In this case, it's going to be somewhere here and somewhere here. What does this imply? See, if C is here, if C is the distance from here to here, and A is the distance from here to there, clearly, you should see that A must be greater than C if you're dealing with an ellipse. This, of course, is going to be different when you're dealing with a hyperbola, as you see later on. So with that in mind, we can easily do the math. So again, since when you have A being greater than C, this difference here will give us a positive solution because A is bigger than C. So if you make a mistake and swap these, you're obviously going to get a negative, which will be complicated when you try to get the square root later on. In our case, A squared is 9 and B squared is 4. So A squared is 9, B squared is 4. Sorry. Yeah, B squared is 4. So we have C squared here and B squared is the one which is 4. So this is what we have here. So from here, we can easily swap them out. The negative C squared goes to the left, it becomes positive. The 4 goes to the right, it becomes negative. So we have C squared being equals to 9 minus 4. Get the difference there. We have a 5 here, and then C ends up being equals to plus or minus the square root of 5. So what this is telling us is that from here, from the center up to where C is, going up, we have positive root 5. Going down, we have negative root 5. So that is where the focus is. Now, what is left? Well, we have sketched the ellipse. We have found where the vertices are. Now, we just have to present them. The sketch is okay. Now we just have to present the vertices so that, since they said we have to step them, but to find them, we have showed them on our graph. Now we just have to present them as solution. So how do we do that? Well, in this case, we're just going to say, okay, our foci, because I'm going to give them both at the same time. Our foci, where is it? So in this case, the foci is basically the in terms of C, where the focus is. So it's here. And when you check out that point, it's in the X, it's at 0. In the Y, you have to go up to root 5. So I can say 0, comma root 5. And the other one, we can say it is down here as the second focus. Second foci. So in this case, we have, this is going to be 0 again in the X and going down to root 5. So that's going to be 0, comma negative root 5. So these are the two foci that we have. Now, they're presented like this, but sometimes you'll find that they can also be compacted and presented as, since both in each case it's a 0, they can also present them as 0, comma, plus or minus root 5. So even this can be used to imply this. So whichever case you get, be able to interpret it accordingly. Okay, that part is done. So we have stated where the foci is. Now next, vertices. So the vertices here are going to be this point right here and this point down here. So if you check that point at the top, that is 0 in the x-axis and 3 in the y. So the vertices. Is there anything else they wanted us to get? So it was the vertices and the foci. Okay, the vertices. That's the last one. Okay, so the vertices, what do we have? So for the vertices, we have 0 in the x, a 5 going up. Was that a 5? Sorry, I think it was on a 5. That's a 3, yes, that's a 3. So 0, 3. And the second vertex is coming down here. So 0 in the x again, minus 3 in the y. Again, same thing. We can easily compact this and present it as 0, plus and minus 3 here. It's not all that you'll be able to compress like this, but especially the ones which are centered at the origin, this will always be possible. Okay, so we're done with this one. So let's do one more, try to be a little bit fast with this one so that you guys can get, but I'll pick something that looks a little bit different. Let's look at this one. So for this one now, what we have is a 16x squared plus 25y squared is equals to 400. Before we proceed, do we have a question on the previous one?
Yes, sir.
Go ahead.
On the vertices, like you have to only show what is major vertices. About the minus.
Okay, the minors we can present them, but usually all they're interested in here are the ones in the major. Of course, you know to say in the minor, this is basically just going to be minus b, and this side is going to be b. So you can also present them, but usually you're only going for the major. Yeah. Okay. So look at this one. So for this one, how do we approach it? Well, this looks a little bit different, because if you check in our standard format, we had x squared over a squared, b, and then we had y squared over b squared is equals to 1. Two things are different here. Firstly, the coefficients here. We had 1 as the coefficient, but we have numbers here. Apart from that, this one here, that's a 400, but in our standard expression, one ellipse, we have the 1. How do we deal with it? Well, the first thing you start by concentrating or focusing on is the right-hand side here. Make this a 1. To make this a 1, you have to divide through by 400. So what you do to the right, do to the left. So how does that happen? So I'll divide both sides by 400. On the left, it just means that each term must be divided by 400. On the right, it's 400 over 400. That is a 1. Well, that's one problem solved. From here now, is it possible to simplify? Well, ask yourself, 16 here goes once. Does 16 go into 400? Does it?
Yes, it can go.
How many times?
5.
25. So in this case, it does 25. In the same way, 25 here goes once because, of course, 16 went 25 times. We expect 25 to go 16 times. So we'll have this, and then this will be over 16 is equals to 1. Now, this is simplified quite perfectly, but I want to just point out one thing here, sidetrack to just make a point here. You can have something where you have maybe 2x squared plus, maybe this is, I can say, 6y squared is equals to, let's say we have, I can say 12. 12 going to be okay? No, let's put something else. Let me put 15. And then here, let me put something like, what is better here? I can put 25. So you have something like this one. You see, if you use the same trick on this question, what you do first, divide by this to ensure that the right side is a 1. But then you have to do the same thing to the left side. Notice that now you will have 2x squared over 25 plus 15 y squared over 25 is equals to 1. You'd have solved that problem. But look at this. 2 does not go into 25 properly. It will leave a remainder. How do you approach it in this case? You can reduce 15 and 25 here. And if you did that, the 15 and the 25 will give you 3 y squared, and this will be over 5. Yes. And then this would be equals to 1. Even here, you have the same thing where it doesn't reduce properly. What you can do is, you see, you still want to make sure that the numerator is just the coefficient of the x squared is a 1, the coefficient of the y squared is a 1. Well, there's a way you can do that. Easy. Here, this term here, the 2 over 25, it can be written as 1 over 25 over 2. And then you have the x squared. In the same way, in other words, the 3 will just go to divide the 5 here, so that you have y squared over 5 over 3 is equals to 1. Do you agree? Well, if you're wondering if this is actually okay, let's take this one, for example. If you were to take that one, that's basically x squared over 25 over 2, which is the same as x squared divided by 25 over 2. When you change the division to multiplication, you know this becomes x squared multiplying 2 over 25. And finally, this becomes 2x squared over 25. See that it reduces to exactly what we had. So this is a trick that you can use should you find yourself in such a situation. Now, once you're done with this, of course, all you have to do now to get what A is and what B is, just remember that this then is the squared term. I wrote 5 over 5 here. This is 5 over 3. Sorry, 5 over 3. Okay, just know that whatever this is will be either A squared or B squared, depending on what you're dealing with. Okay, any questions on that one, on that trick? Okay, looks like that trick has been understood. Just look out for that. Sometimes they'll just throw it into just confusing. But the kind of them, it reduced just fine, and this is what we have. Once we have reached this stage, you can now clearly observe that this is bigger. The denominator of the x squared term is the bigger one. So you know this one is going to have a measure in the x-axis. So I'll start with a sketch. I always like starting with a sketch because it's easy for me to see where everything goes when I have the sketch. Because it's easy for me to pick where the vertices are, where the focus is when I'm dealing with a sketch. Okay, so my measure is in the x-axis. Let me place it there. So this is my ellipse, something like that. Now, how do I work with it? Well, firstly, from here, clearly the bigger one gets to be a squared. So I have a squared is equals to 25. This implies that a is going to be plus and minus 5. So from here, I can conclude that this is at minus 5 and this is at plus 5. That's one part done. Next, I need to figure out where the foci is. So I know one has to be here. I know one has to be here. This 16 gives me B. To get the foci, I need to know what C is. So let me first get B from the fact that B squared is equals to 16. And from there, I know that B will be equals to plus or minus 4. Then, knowing what B is, we can now get C. We know that B squared is equals to A squared minus C squared. So that C squared is equals to A squared minus B squared. Finally, C squared, our B squared is 16. So that C squared will be equals to the difference there, 9. And knowing C squared, we can get C as plus or minus 3. Having figured out that, we now know what C is, can place it there, minus 3 and positive 3. So we have figured out what C is. We have our sketch, everything is in place. We can now answer the question. So we have the sketch, therefore, the foci. I use the compact version. Notice in this case, in the x-axis, you are moving. So in the x-axis, you have minus 3 and plus 3. Again, this can be compacted into plus and minus 3. In the y-axis, there is no change. In the y-axis, it's the same thing because in the y-axis, both points has a 0 in the y-axis. So because of that, this is plus or minus 3, 0. That becomes the foci. Next, we need the vertex. For the vertex, what do we have? Again, two of them. We have one at minus 5, the other one at 5. In the vertical axis, they're both at 0. So this is minus 5, 0. And the other one is plus 5, 0. Again, I can compact them into just plus or minus 5, 0. So this becomes the vertex. Any questions? Okay, looks like we're fine. Okay, so with the first part done, we can now try to see if we can look at some more examples. Now, you guys can try to see if you can work out some of these questions here. Try to see if you can practice with this. And of course, try to see if you can make a conclusion. What conclusion you can make about the type of shape you're going to end up with there. You're going to be classified as an ellipse, but what else can you say about it? So let's see what you guys are going to do about that. In the meantime, let's look at the second type of questions you can encounter when dealing with the ellipse. So let's look at these. Now, in the first case, they gave you the equation and you had to determine the focus and the vertices. Now, in the second type of questions now we're saying, what if they did the opposite? What if they gave you the foci and the vertices, and then now they're asking you to say, can you find the standard form equation for the given information? So this is what we want to see now. It's pretty much similar, but we're just going to be doing exactly what we're doing, but just in reverse. Look at the first one. Again, the question, in each case, find the ellipse standard form equation for the given information. The first one, they've given us the foci. That's plus or minus. Again, they're using the compact form, √2, 0. And what else are they saying? Same for this one, the vertices. The vertices are at plus or minus 2, 0. So let's see if we can get what they want us to find about this shape. So as always, if you guys notice to say that I've made an error or anywhere, please don't hesitate. Sometimes when you have to explain while working out these questions, it's easy to make a mistake. But feel free to correct me if you observe something or to challenge whatever I say, if you think it's wrong, of course. So look at this one now. So for this one, the first thing you have to do is, of course, I want to start with my drawing, my sketch, but I want to figure out one thing first. In my sketch, what type of ellipse am I dealing with? Am I dealing with my major in the x-axis, or am I seeing my major in the y-axis? So that's the first thing I want to answer. Well, let's see. Let's suppose my major was in the y-axis. I'll start with this one. So if my major was in the y-axis, what would I observe? Well, if my major was in the y-axis, then I see that in this case, again, these are centered at the origin. If my major was in the y-axis, then I expect that the coordinate, for example, of the vertices would be given in terms of 0 in the x, and it would be a that would have a value. So this would be the one that would have a value, and this would be 0. Even if they are not centered at the origin, it means the two vertices would be different, but they'll have one similarity. The major, they will have the same unit of the major. What I mean is, even if our ellipse was like this, as long as it has the major in the y-axis, when given the vertices, the value here will have, let's say this is an A and this is a negative A. Notice that the first value, the x, I'm saying this is now off center. It was, let's say, like this. Let's say in the x-axis, this is perhaps at h or something. Yeah, somewhere else at h. Notice that each of these points would have h, a. The other vertex down here would have h, negative a. Again, they have the same h. This is how I know that the major is in the y-axis. We'll come back to that point, I think, when we look at the ones which are off center, or when you start looking at other components. But for now, the fact that this is a 0 here, and A is up there, and here I have a 0 here, and this is negative. I know to say when this is the only thing changing, then I know my measure is in the y-axis. And if I had something like this, measure in the x-axis, what would be different? Well, in this case, I see that this would be negative a, comma 0 in the y, and this would be positive a, comma 0. So in other words, when the measure is in the x, it's y which is similar. This value of y has to be the same as that value of y. In this case, they're both zeros. So when we take it to our question, what happens? Look at this one. For this one, we see to say that the y value for the foci is the same. The x value is the one changing. Clearly, this tells us that the foci or the measure here is basically in the x-axis. You can observe the same thing even for the vertices. It's the x value which is changing, and the y value is 0. So if we had created a sketch for this one, how would it look like? Would have this, and then our ellipse. From the compact version, you should be able to interpret it to say that this is plus and minus root 2. The minus will be here. This will be the minus root 2. These are x values. And the plus root 2 will be here. And notice that this is root 2, comma 0, and this is minus root 2, comma 0. Sorry, that is the vertices. Yeah, I think someone observed that the vertices. Since this is for the foci, it's not here. The foci is here and here. So this is where we have minus root 2, and this is where we have plus root 2. And then for the vertices, we have this one. So we have minus 2, and we have plus 2. So that is what we have there. So we have sketched it. Well, even if you are not able to, let's say, move straight away from here to the sketch, you can still use this first to come up with the standard equation, then create the sketch as we did in the first part. How do you use these to come up with the equation? Here's what you do. Okay, so let's come up with the equation using these as well. So if you're using these to come up with the equation, all you have to remember is this. For the foci, how does it work? Well, the foci, this is where the focus is. So you don't say the focus goes with C. That is where C will come from for the focus. And from the vertices, what do you get? The vertices, you get A. So this is the information that you're going to get. So what does it mean? You see, here, it implies that since this has the center at 0, 0, this is the coordinate of the center, and that one there. Yeah, so how will it go here? So here, this is, if I was to write this in its general sense, this will be plus or minus C, 0, and the vertices, this would be plus or minus A, 0. In other words, this represents what C is. C is equals to plus or minus root 2. And this represents the vertices. The vertices, we have A being equal to plus or minus 2. Once you have what A and what C is, you can find what B is. Because, of course, you know to say A squared will have to be 4, A squared that is, and C squared, the square root, not the square root. If I have root 2 and I have to square it, I know to say I'll just get 2. So we know to say for an ellipse, we have B squared is equals to A squared minus C squared. A squared is 4. C squared is 2. So we have B squared is equals to 4 minus 2. We have 2. So that B is equals to root 2. Once we have this, we can now come up with a general formula. Plus y squared over b squared is equals to 1. All you want to look out for is, since we concluded by observing the position of these values, we concluded that the measure is in the x-axis. Because the measure is in the x-axis, our conclusion is that of these two, x will have the bigger value. So when I compare b and a, the bigger one, or my values for b and a squared has a 4, b squared has √2. Clearly, a squared is bigger, meaning the denominator for x will be the one, which is 4. The denominator for y squared would take 2. So this is b squared there. So this becomes the general formula. Is that okay? Any questions? So you guys can try out this one. Okay, so you guys can try out this one there. Okay, so in the second part of our class, we're not going to look at the ellipse again, but now I want to look at the ellipse which is centered off the origin. So in the first part, we're looking at the ellipse which was centered at the origin, and we sort of say that one had a standard equation that looked like this, and then we were able to sketch that ellipse given the equation, or given the necessary information, we're able to get the standard equation. Now, what if it was centered somewhere else, away from the origin? In our previous class, we started to say that the general formula such an ellipse, let's say it is centered somewhere like at, let's say, h, okay, such an ellipse would have a general formula which would have x minus h squared or a squared plus y minus k squared over b squared is equals to 1. So such an ellipse would have this as the general formula. Now what we want to see is, how do you sketch it if you're given the general formula? Now let's use part 1 there as an example. Then you guys will try out part 2 for your practice. So in this example, we have x minus 4 over 16. This is squared. Then we have plus y minus 3 squared over 9 is equal to 1. And the question is, find the foci, the vertices, not the added the center. Sketch. So how do we approach this type? The similar approach, really. The only difference is now we're not at the origin. So like before, I want to start with a sketch. So let me create the coordinate plane. Okay, so this is what we have. Next, when I look at the denominators, I see that the denominator associated with the x term is bigger than the other, meaning I know it's an ellipse which is more horizontal. But where is its center, since the center is not at the origin? Well, in this case, we recall when we look at this, the x coordinate of the center is here, and the y coordinate is here, and the sign on the middle is a minus. So with that in mind, what does it mean? If we had, let's say, a plus here, it would mean that h has to be -4. That is, if this is positive here. But because this is negative, because the 4 here, the sign on the middle here is negative, and in the general formula it's a minus, it implies that h is +4. The same thing is observed here. It means that k is +3. So the center for our ellipse is at 4, 3. once we have figured out where our center is, we can now create a skeleton for our ellipse. Now, for this one, I really want to be careful because I know it's at 4,3. I can approximate, say, okay, let's say 4 is here, and 3, let's say 3 is here. Now, it's possible. All I know is the center is here. But how far does the ellipse go? Is it something as small as this? Or maybe it's an ellipse that goes like this. Or maybe it even goes like that. So you really want to be careful here. Unlike the one which was centered at the origin, I can't just draw the lines anyhow. I need to know exactly where the vertices are in advance before creating that sketch. So what I'll do is I'll just indicate that my center is here at 4,3. Now I need to find where the vertices are. So let's go back to this point. To get the vertices, if you recall, we need to know what A is. All we know is that our ellipse is horizontal. Because it is horizontal, it's going to be more like this. But we just want to be sure how far wide it stretches. So, like I said, the bigger one becomes our A, and the smaller one becomes our A squared, and the smaller one becomes our B squared. This statement will only be valid for an ellipse, for a hyperbola, something else. So we see that A squared is 16, according to this, and B squared is 9. So since B squared is equals to A squared minus C squared, we see that we can easily find C squared by just saying A squared minus B squared. A squared is 16, B squared is 9, so that the difference becomes, what's that? The difference becomes, is it a 7? Is it 7? I think so. So C squared is equals to 7. Since C squared is 7, it means that C is root 7. And of course, since B squared is 9, it means that B is a 3. And of course, we'll not say plus and minus, but for now, just look at it as a 3. And A is a 4. Now that I have these, what it means or where we are, this might get interesting. We need to pay attention to this part. Sometimes students tend to make mistakes. It's very easy, I have to say, but it's easy to make a mistake as well. Okay, you know where the center is. But how do you use those terms A, B, C? Now, it doesn't. You know, to say A is where the A has to do with the vertices, but it doesn't necessarily mean that you're going to have negative. Doesn't mean that the vertices are going to be at -3 and +3, whereas the vertices, okay, A is 4 and the other one is 3. Okay. So here, it doesn't necessarily mean that the vertices will be at -4 and the other one will be at +4. It doesn't mean that, but instead, what it means here is the H term, the coordinate, the center, the H term. To the H term, subtract 4, subtract H, not subtract H, subtract the vertex, subtract A, and the H term is a 4. A is 4 as well. When I subtract 4, it tells me where the first vertex, since I'm subtracting, it tells me where the vertex to the left is. So when I move 4 units, it takes me to this point. So this tells me to say that the first vertex is here. I know I'm dealing with something like this. What else? To find the vertex to the right, going this side, to the H coordinate, I need to add A as well. So remember, A is the distance from the center to the vertex. So from here to there. This is why I'm saying, since on the X scale, this is H. So to reach this mark, I must add A, because A is the distance from here to there. So to H, If I added A, I'll get where this point is. So this point will be H plus A. And if I was moving from here going backwards this side, then this point here would have to be H minus A. This is why I just said to reach this point here, I'll just say H, which is 4, minus, since A is 4, minus 4. This is why I did that. In the same way, to find the next one, going to the right, H is 4 plus 4, it takes me to 8. So I know the other one will be at 8. So I know where the vertical vertices are, the other vertices, these vertices are going to be. I know I'm dealing with something like this. So I know this is what I have. The next thing that I need to understand here is this. How far down does it stretch? I know where the vertices are now. I know this is at 8. I know the other one is at 0 there. But I'm trying to understand this ellipse. You see, it can stretch in so many different ways. It can even go up to something like that. Or it can just be like this. It can even be way too thin like this. So I need to kind of have an idea of how thick it is. So to figure out how thick it is, I now need to understand the displacement from the center. How far down do I have to move before I reach the minor vertices? So before I reach there, then how far do I have to move to reach the upper one? Now to do this, this is where I'll use B, because that distance is B and this distance is B. But this, notice that it affects the Y value of the center. What do I mean? You see, this point here at the center, in terms of the Y value, that is a 3. So we find B to be root 7. So to know how far up I have to move to reach this mark, I know I have to add to 3 up to add root 7. Because sorry, C, that root 7 is the focus, not B. Here is B, since this distance here is B. And RB is what? Right? RB is 3. So since this is 3 here, I need to add 3 to it. So the upper part goes to 3. Now, the lower part as well, since this is a 3, when I subtract 3 from it, since going down, I have to subtract 3, it becomes 0. And guess what? 0 is down here. So I know my ellipse has to stretch all the way down up to there. Now I can sketch my ellipse properly. I know it passes here. I know it passes here. I know it passes here. And upwards, I know it passes there. So that this side, that is at 6 when I add 3 to that. Once you have this, you can now create a sketch for your ellipse. It doesn't have to be perfect, but try by all means to draw something that adds up. So of course, my phone will finish everything so that I have this. So there, we have our ellipse. So I just want to make sure it touches the x-axis. It has to touch the x-axis just at that point. So this is what we have. This is the ellipse they wanted. So we have created the sketch. The only thing that is left here is the foci. We know to say for those, one has to be somewhere here, the other one has to be somewhere here. Again, notice that C, which tells us where the foci is, it's a measure from the center, and the center is here. So you have to see, it's C, this distance up to there, that distance is a C, and from here, also stretching up to here, this distance is C. What does it mean? Since the center is at 4, it implies that the x value down here is going to be 4 minus C. And C was root 7. So to 4, if you subtract root 7, it will give you what this x coordinate for that one is. And to 4, if you add root 7, it will tell you the x coordinate of this focus. So this is going to be 4 plus root 7. This is the only trick that you have to keep in mind when dealing with conic sections which are off the origin. Let's take these values now. So let's start with the vertices. For the vertices, what do we have? So for the vertices here, you see to say it's at 3, and the other one is, no, this is at 0 in the x, this is at 8. So we can't really compact them, but anyway, 3 is the same. This is 3, that is 3, but we can't really compact them here because 1 is 0, 1 is 8. It was easier when it was 1 is negative, 1 is positive. So for this one here, it's at 0, 3. So the first one is at 0, 3. And the other vertex, the vertex at the far end, is at 8, 3. So these are the vertices. Now let's look at foci. What do we see? The first one, this is at 4 minus root 7 in the x, comma, in the y, it's at 3. So this is comma 3. And the other one, the other one is at 4 plus root 7 in the x, comma 3 as well. Comma 3. So these are the foci. Next, we have the center. The question wanted us to find the center, the foci, and the vertices. The center, we did find it earlier on. We wrote it, I think it was, it was at 4, 3. So we can include it here. Center, it's 4, 3. And our sketches here, everything, all the points which matter on our ellipse have been included. So basically, this is what you have to do to create the sketch. Any questions? Okay, so you guys can try out this one here. Let me just zoom in so that you guys can see it. So try to see if you can work out this. And it's the same thing, sketch it, find the vertices, the foci, and the center for this ellipse. Okay, I think this is all we'll do for tonight. Next time we meet, we're going to look at the hyperbola, and we're going to do everything on the hyperbola as well.